Welcome to microprocessor tutorial. Now introduction to microprocessor. The first question is where we will see the microprocessor. It is a very basic question. We can see the microprocessor in computers, laptops or mobile phones or any such electronic devices definitely having microprocessor. So if you go to market, if you want to buy a computer or mobile phone, first you have to see what is the processor. Nowadays in the market you will see i7, i9 processor like that. So whatever it may be, or the latest processor or the first processor 8085 or 8086, the basic operation is same. If you able to understand any of the processor, then it is very easy to understand the other processors also. Like if you learn any car driving, then you can drive any other car. So that we have to understand clearly any of the processor. So the basic components of the any processors are, one is ALU, arithmetic and logic unit. By the name itself, it performs arithmetical and logical operation. The second one is control unit. The control unit, it controls the ALU. That means which operation has to be done by the controller. Which operation has to be done by the ALU, it is controlled by the control unit. Now the third part is registers. Registers are the storing elements which stores the operands which has to be performed. Okay, now we will see in detail about these three parts. Now see these three parts in detail. ALU, arithmetic logical unit. So for better understanding, in this circuit I am assuming four logic circuits are there. This one is adder circuit. This one is subtractor. This one is multiplier, and this one is divider. These are the logic circuit which are designed with the logic gates. We know very well about these logic circuits in the digital electronics. So these are designed with the logic gates, AND gate, NOR gate, like that. And for better understanding, just I am taking here four logic circuits in the ALU. Okay, that means this ALU can perform addition operation, subtraction, multiplication and division operation only. Okay, now you are having two operands, that is suppose 10, 15, whatever it may be, any number. These are operands. It is called operands because the operation has done on these things. That's why these are calling operands. Okay, now these some operation has to be performed on these two operands. That may be addition operation, subtraction, multiplication or division. So we know the computer not having mind, it cannot take own decision. uh, it cannot perform addition, subtraction by its own. You have to say to computer which operation has to be done. So that's how you can say to the computer, to the ALU, to the processor, you that can be say by the control unit. Here, control unit is also a combination circuit. Inside this, some logic circuit is designed. Suppose here this control unit having two input lines and four output lines. Okay, this is a combinational circuit. We know very well about the combinational circuit in digital electronics. So now here these two input lines, if you give here 0 0, then for these four lines the high signal is will go to this adder circuit, and here addition operation is done. If you give here 0 1, then high signal will go to this circuit, subtractor circuit, and subtraction operation is done on these operands. If you give here 1 0, and then the high signal will go to multiplier circuit, and multiplication operation is done on these operands. If you give here 1 1, then high signal will go to divider circuit, and division operation is done. Okay, now the where you have to put these operands, can we put these operands on air? That's not possible. It requires some space, like if you take banana or mango, whatever it may be, and you want to perform some operation on the mixie, so you have to place it some storage place, that is jar. So similarly, these operands has to be stored somewhere in the processor. That place is registers. Registers are the storing elements where operands are placed. Now these operands are placed in the registers. Okay, now my question is that these are called here opcodes, operation codes. This is also in machine language code. By this code is decoded here in the control unit, and particular signal is given to the ALU. According to that signal, the performance is done by the ALU. Now here this is for simple circuit I am taken for understanding, but in actual case ALU can perform a large number of operations. As the operation number increasing, this size of the opcode also increases. In such case, it is very difficult to remember. So suppose there are only four mobile phone numbers, then it is easy to remember. But 104 numbers, it is difficult to remember. In such case, what you will do? You will use phone book. In phone book, for particular number, you will assign a name and store. Okay. Similarly, here assembler is there. This is the assembler. Assembler is a software, just like a phone book. Okay. So here in the assembler, for add, for 00, you will save in the assembler like add. If you write add, it goes to the assembler. In the assembler, add is assigned to 00, so 00 will go to the control unit, and from here control unit high signal will go to the adder. Addition operation is done. If you write here sub, if you write sub, then it will go to assembler. In the assembler, that sub is converted as 01, and this 01 go to the control unit, and from control unit then high signal will go to the subtractor circuit. Then on these two operations, subtraction has to be done. So similarly, so for here for multiplication, the opcode is 10, and for division the opcode is 11. Here in the simple case, for better understanding, I am taking only 2-bit opcode. This is called opcodes, 2-bit opcodes, but in actual case opcode size will be increased. Okay, so these four are called instructions. instructions. So thank you.